Welcome everyone for joining us this week. You are currently visiting the weekly Space Hangout. I am not Fraser Cain. I'm Dr. Pamela Gay. I'm a professor at Southern Illinois University, Edwardsville, and I blog at starstrider.com. I'm taking Fraser's place this week because he's off in Europe with his children having a wonderful vacation, and the internets were not with him this evening. I'm coming to you as a picture because the internets are only somewhat with me, so I'm going to very quickly get other people who have live avatars talking and talking live science. So I'm going to start by introducing the people who are here in the Hangout with me and then moving on to their topics. So going from left to right as I see them, we have Alan Boyle from MSNBC and Cosmic Log, Emily Lakdawalla of the Planetary Society and Planetary Society blog, and Ian O'Neill, who's Astro Engine on Twitter and is the editor of Discovery News. And if you're following on Twitter, Alan is Boyle with a 0 and Emily is E. Lakdawalla. And if everyone could +1, that would be fabulous. So I'm going to start with Alan this morning. And Alan, you bring us news of HiRISE and Mars.
Well, I'm still kind of working on the follow-up to this story, but last week the big deal among amateur astronomers, at least some of the amateur astronomers who look at Mars on a pretty regular basis, was this strange cloud that people were seeing on the limb of the Martian disk, and wondering what it was. It's in the southern hemisphere. Some people were saying it was rising as high as 150 miles, and so there was a lot of head scratching about what was going on, and everyone was anxious to hear what the professionals had to say about this. And so I checked with some of the professionals, and the folks at Themis, which is a thermal imager on the Mars Odyssey probe, were actually interested in looking at this cloud, and they're trying to do that right now. They've gotten some images back. They're not really seeing anything, which is an interesting part of the story. And they're also looking at other clouds that are around the large shield volcanoes of Mars, and so this is a good season for looking at that atmospheric phenomena. So now I've heard from the folks at HiRISE who point out that this isn't really the sort of thing that they're able to look at. It turns out that this is a cloud on the edge of the disk, and you can't really see it when the disk turns full to face the imager. And it turns out that this sort of thing has been seen before, and the professionals do kind of know what this is. The folks who were involved with Mars Global Surveyor have seen this sort of cloud before, and these are the sorts of clouds that form in the morning on Mars as the sunward limb of the disk is turning into view, and they dissipate. And so people are trying to assess just how big a deal this is, but we don't have to worry that the UFOs are coming to get us from the red planet, that this is a totally natural phenomenon, a little interesting for the atmospheric scientists, but nothing that the UFO crowd should get excited about.
And it should be pointed out that the people who did the cameras,
it's been a lot of excitement for the astrophotographers and a lot of...
You seem to be on a delay, Pamela. It should be pointed out that the people who were on Mars Global Surveyor are the ones who have a camera on, they do have a camera on Mars Reconnaissance Orbiter. It's not HiRISE, it's called MARCI, and I forget now what MARCI stands for, but it's a camera that takes strips of images covering all of Mars once a day, and they use that actually for weather observations, and they do a weekly weather report on their website. It's Mail and Space Science Systems, and if you search on MARCI, M-A-R-C-I, on their website, you'll find their weekly weather reports.
Yep. MARCI hasn't really seen a whole lot of related to this particular phenomenon, but they're definitely looking at the MARCI imagery as well.
So this is just an exciting bit of Earth-based planetary news, but the meeting that we were at last week, we being Emily and Nancy, who wasn't able to make it this week, and myself, we were getting a whole lot of space-based news coming to us from all of the missions that are out exploring the inner and outer solar system. And Emily is going to bring us a roundup of a lot of the highlights of what we saw there. So Emily, I hand this over to you.
Honestly, I hardly know where to begin. This was such a productive meeting, and it might be because I didn't get to go to the Lunar and Planetary Science Conference last year that it seemed like so much, but so many scientists were saying that this was just a great meeting this year. There were results from Messenger at Mercury, there were results from Dawn at Vesta, there was the latest update on Opportunity exploring Endeavour Crater at Mars, there was news about rain and weather changing on Titan and Saturn, and then little bits and pieces from all the rest of the solar system. So I'll just try to hit a couple of the highlights. A big one was definitely the results from Messenger at Mercury, because last year at this time they had just arrived in their science orbit, so they really didn't have a lot of major results. They were just like, here, look at our cool new pictures. But this year they've had a year of new results to work with. And it's amazing what they've managed to do to show that Mercury is its own planet. It's very different from the Moon. It's very different from Mars or Earth. It has this, the topography of the planet is really key to understanding its geologic history, and there are some very weird things. One of them is that it has a gigantic basin called Caloris. We've seen Caloris ever since Mariner 10 flew by. And you can tell it's an impact basin. It's got a couple of concentric rings around it. But if you look at its topography, the shape of the landscape, there are actually now areas of its floor that are higher than areas of its rim. So clearly its topography has completely changed since it first formed. And this change in topography, it's just kind of exemplary of how the topography of all of Mercury has these long linear belts of ridges and troughs that are organized into these systems that are a lot more like Earth fold and thrust belts than they are like anything that we've seen on other planets, which to me as a geologist is very exciting. There's also this interesting area of flood basalts near its north pole. It covers, I think they say, 6% of the planet, which is really quite a large area to be covered by one area of volcanic flows. And the cool thing is that, so the basalts, it's lava that came out as a liquid. It filled up craters, made nice little ponds in the craters. But since those ponds dried up and became solid rock, the whole area where that volcanism happened has inflated. It's grown this sort of rise in the middle, and you can tell that not just because there's a rise there now, but because all those crater floors are tilted out from the center. You can actually tell that with the topography. So that's very cool. They also showed that from gravity data, they have a model of what the interior of Mercury looks like. They have shown previously that there was a liquid outer core, but now they're advancing an argument that the core actually has, uniquely in the solar system, has 3 layers, that it has a solid iron outer layer, actually iron pyrite, iron sulfide, a liquid center layer, and a solid core. And they invoke this in order to explain some odd things about the shape of its gravity field, although I actually talked to some other scientists at the conference who are dubious about this interpretation, so stay tuned for that one. Speaking of gravity, Cassini has produced some gravitational measurements that tell you about the interior structures of some of the moons of Saturn. They found that Enceladus has its mass concentrated toward the center, and so does Dione. These things were expected. But I think one of the most important results of their gravity surveys has been that they have shown that Titan, as suspected, this is the biggest moon of Saturn, the one with the weather and the methane channels on its surface, that Titan has a liquid interior layer. It has to, in order for its shape to change the way it does as it moves around Saturn, as tides change its shape. And this is really a huge achievement, proving with the gravity data that there is an ocean under Titan. This proving that an ocean exists using gravity surveys is one of the main scientific drivers for us to send a future mission to Europa. So the fact that they were able to do it with an orbiter that was orbiting only Saturn and not just Titan is really a huge achievement, and shows us that you might be able to do the same thing at Europa and Ganymede with a single orbiter orbiting Jupiter. instead of requiring an orbiter to go into orbit around Europa. Now, of course, you get better gravity data with the Europa orbiter than with a Jupiter orbiter, but still, you could prove or disprove the existence of that ocean with an orbiter in orbit around Jupiter, which is pretty cool. And then there's, let's see, the latest from Opportunity at Endeavour Crater is that it's driven onto Cape York and found a type of rock called swavite. And a swavite is a rock that has, it's a breccia, which means it's a rock made up of broken bits of other rock, very angular broken bits. So you know that these things didn't get a long opportunity to be eroded before they were glued back together into rock. And they're glued back together inside this fine grained matrix. The crystals are so tiny that you know that it must have solidified very fast. And so this type of rock is very typical of impact craters on Earth. So we knew that Endeavour was an impact crater, but now we have proof that we're standing on some of the solidified material that was thrown out of the impact crater by the impact that created it. And so we are looking at those very ancient rocks that existed before the impact happened. Inside the broken up bits of rock that are in the swavite, those are very, very ancient rocks, much older than anything that Opportunity has seen before. So now we know that she's in the right place. However, Opportunity has not yet found clay minerals, which is one of the reasons that she was driven all the way to Endeavour Crater. They didn't really expect to find those on the particular spot of the rim where she is now. So after the winter is over, and they've just passed winter solstice, power levels are beginning to come back up. They're going to finish up at Cape York and head southward toward the mountains that Opportunity can see. And they're actually going to start climbing mountains with Opportunity, which is, it's amazing. Spirit did this earlier in her mission, but Opportunity has always been on absolutely flat landscapes. So the fact that Opportunity is going to get to start climbing mountains is making the geologists just salivate. They're so excited. So that's just a couple of the updates from LPSC, and there is just so much more. It's going to take me weeks to write up all of these things that I have in my notes.
It was a truly amazing meeting, and one story that I asked you to leave for me, and I'm now going to take the host's prerogative to jump in and share one bit of news, was they have pretty much determined that Titan has rainstorms. There was, right after Saturn passed through equinox, a large band of shiny white clouds that were spotted along the equatorial region on Titan. And as these shiny clouds rotated through and the storm dissipated, the land mass that had been underneath these clouds was revealed to be, for the most part, substantially darker than it had been prior to these clouds forming their storm. But in addition to these large swaths of darkened landscape, there were also areas where there was much lighter material. And as they watched over time, as we've moved past equinox and started to watch the changing of the seasons on Saturn, we've seen the darkened landscapes return to their normal color, and the light landscapes also return to their color, but without darkening. And that's actually kind of key, because here on the planet Earth, we see after rain, when we fly over, take satellite images of area of the plains, of croplands, where you can see the soil underneath. We see swaths of this land that is substantially darker, and as it dries out, it returns to its normal color in a patched manner where you can see where the water's been pooling. That exactly matched the drying patterns that were seen on Titan. But here on Earth, where we see shiny stuff, otherwise known as snow and ice, after a storm has finished passing by, that snow and ice melts, leaving a dark landscape behind. Well, they still haven't fully figured out how to explain the shiny stuff on Titan, the snow and ice looking stuff on Titan. But what they think may be happening is it's some sort of a volatile, some sort of an ice that is going straight from being a solid crystallized on the surface of different features on Titan to being a gas. So this could be something like dry ice, for instance. And by bypassing that liquid phase, going straight from a solid to an atmospheric gas, it's able to essentially dry up without ever melting out. And it's really amazing to watch how we're seeing Titan is, with its lesser gravity, still a complete geographic system with rains, with waters, with channels, with all the different things we see on Earth, but using a different liquid that, because of the lower gravity, is able to respond just like water. Physics sometimes does awesome things. And we weren't the only ones who got to get excited about planetary stuff. This week, Ian also got excited, but he was looking at stuff out of our solar system. So I'm going to pass things over to Ian now and ask him to talk about ancient exoplanets.
Yeah, there's been pretty exciting news from the exoplanet community. And in fact, I do have some really exciting solar system news that's actually just cropped up this morning, but I'll go on to that straight after my exoplanets. And so basically the researchers from the Max Planck Institute in Germany, they released news that they discovered two planets orbiting a metal-poor star. Now, it all sounds very boring. I mean, Metalpoor, what's that mean? Why is this so incredible for the discovery of these exoplanets? Basically, if you think back to the dawn of time, back to when the Big Bang happened, only in the first billion years, right around that time, the first generation of stars were created. And of course, back then, the universe was just filled with hydrogen, with very, very basic elements. So these stars, they didn't have any elements heavier than hydrogen, helium, and some lithium. And so it took a long time for these elements to form over the history of our universe. But the discovery of a star that's considered metal-poor also suggests it's very, very old. So this star is actually estimated to be around about 13 billion years old. And you can tell that just by understanding the elements that are inside the star. Now, to find planets in orbit around such a star is weird, because that means these planets formed around the same time the star formed. So that means these planets formed when the universe was probably only about 1 billion years old. So these planets are ancient objects. And also, it kind of throws a spanner in the works, because anybody who's with planetary formation theories, metals, or at least elements that are heavier than the ones that are found inside the star, they're the ones that actually form planets. And it's not completely understood how planets can form in such around the orbits of such low metal stars, low metallicity stars. But I spoke to the lead scientist in charge of this research, and he said actually it's just a matter of perspective, because back in the dawn of time, this particular star was actually very, very metal rich compared to other stars. So if planets could possibly form, this would be the kind of star that they would form by. And of course, it's only now in our modern universe that it's metal poor. It looks as if it shouldn't have any planets, but it just means these planets formed over a longer period of time. So yeah, it's very exciting, and also it sets a new record, because we haven't found exoplanets that have that are this old, especially in our Milky Way. And it looks like this star was actually probably a remnant of a galactic collision several billion years ago between the Milky Way and an older galaxy. So there's a lot of factors involved in this research, and it's not just about finding two planets around a metal-poor star, which is weird in itself. It's actually a monumental discovery in a way. And if you can imagine in the far-flung future, we'd probably have Indiana Joneses of our race going to such a system to study these worlds for an archaeological dig, not necessarily to look for life, because there's no indication that any components for life exist around the star. But it's certainly an interesting place to go and visit, because these are artifacts from the dawn of our universe. So that was really cool, and I really enjoyed that. But then I got a message from my old institution at Aberystwyth University in Wales in the UK. I used to work in their solar physics group, and my main research was a little bit closer to home. It was actually in the atmosphere of the sun. And only yesterday I got the message just saying that they were going to be at a conference in the UK presenting a paper, and they'd actually discovered solar tornadoes Now, these tornadoes are huge things. They're actually rooted on the surface of the sun, and they reach very, very high into the solar atmosphere, or the corona. And they are basically superheated funnels of plasma wisping around these magnetic fields. And this is the first time that they've ever been videoed. I mean, there's been previous observations deep inside the corona by solar observatories that suggest that these things did exist, these wonderful arcs of prominence, as they're called. They're basically these arcs of plasma that reach out from the surface of the sun and reach high into the corona. But this is the first time that these tornadoes, these twisters that are reaching around and developing and coiling around in plasma and twisting in the magnetic field, have been actually videoed, because we've got a wonderful piece of kit in space right now. It was launched in 2009, and that's the Solar Dynamics Observatory. It's my personal favorite mission of all time. And it's able to look very deep into the corona at very high definition. So forget your high definition TV. This thing can take incredible imagery of very fine structure in the lower corona. And also it can capture them very quickly. So it can put together a really neat video of these dynamic events going on deep inside the corona. So my research group, and in fact it was my old PhD supervisor, Jing Li, him and his research group actually managed to get the first videos of these tornadoes. And I just think they're incredible. And I kind of made me itch to get back into solar research, because that would have been the project I would have been working on right now. But you can't have it all.
No, it's definitely a balancing act, trying to figure out how to do everything at once. And anytime you want to suggest citizen science to do this, we'll work on getting everyone doing it in their spare time. But for now, cool. Right now, yeah, there's ways. We'll find the ways that we can all do all of it. But before we go on to taking questions from the audience, and please log in to Emily's feed on Google Plus to put your questions. Alan Boyle had one more story that comes from not the surface of the Earth, but actually below the ocean. So go ahead, Alan.
Oh, I know. Ian has written about this too, but billionaires, once they make their fortune in the dot-com industry, they like to spend it on space. And we see that with Paul Allen and Richard Branson and Elon Musk spends $100 million on SpaceX. So Jeff Bezos, who founded Amazon.com, is a great example of this. After making his billions on Amazon, he has set up a venture called Blue Origin to try to create rockets capable of going first to suborbit and then to orbit. And another interest that just came to light really yesterday was his quest to find the rocket engines from the Apollo 11 Saturn V. These F-1 rocket engines are the ones that really got the Apollo 11 crew on their first leg to their journey to the moon, and are of great historical significance. But of course, they dropped off when the first stage separated 5 minutes after launch and fell into the Atlantic. And there they've been for more than 40 years. And about a year ago, Jeff Bezos thought it would be really cool to try to see if he could find these things. And so he recruited a team of underwater salvage experts, went out there and announced yesterday that he's found those engines and wants to bring them up to the surface and put them in museums. And so that's going to be the next step. Everybody's the interest in ocean exploration has really taken off just in the last year or two. James Cameron just last week went down to the Mariana Trench, became the first person in something like 42 years to go down that deep to the deepest part of the ocean. And so here again, someone is going to have to go down to a depth of 14,000 feet in the Atlantic and pick these up. I talked with the guy who actually did this sort of thing before, Kurt Newport, who lifted up the Liberty Bell 7 capsule that Gus Grissom used during his space trip. And he said this is not going to be an easy thing to do, that these things weigh 9 tons each. And after lying down there for so long. They may be corroded. It's thought that the first stage of the Saturn broke apart on the way down due to aerodynamic forces. And so I think we've got a real adventure in the making. Some people have asked, why would you spend so much money to do this sort of thing? And Jeff said it's because of its inspirational value. Just as he was inspired when he was 5 years old by the space program, going to the moon, he felt that having these things brought up could be an inspiration to the next generation. He pretty much acknowledges that these are NASA's property, and NASA can do what they want with them. One is likely to go to the Smithsonian, but Jeff would really like another one to come here to our neck of the woods in Seattle and go to the Museum of Flight. And just in the next couple of months, the Museum of Flight is going to be getting this full fuselage shuttle trainer, which is the mock-up that was used to train the astronauts at Johnson Space Center. So Seattle is not so much on the path for the future of spaceflight, but who knows, maybe this part of the country is going to be raising its profile, in part because of the things that folks like Jeff Bezos are doing. So it'll be interesting to watch.
I have visited the Seattle Museum of Flight, and I can attest that it's really a fantastic museum. So if you do find yourself in Seattle for any period of time, I heartily encourage you to go visit it.
This summer is going to be prime time. And that's it.
We're having problems with lag. Apologies to the audience. It's really amazing out there, all the different ways that people are finding to get data, to inspire, to continue exploration however we can. And I have to thank all of you for the reporting you did. And now we're going to turn to the audience, and we have a couple of questions already. The first one is coming from, I think it's Leon Denitson, and he's asking, does being so close to the sun affect the number of impacts Mercury gets? Does it get less or more than a similar body would if it was somewhere else in the solar system?
I think it's Ian Deniston, and yes, as a matter of fact, it does. The amount of craters that any planet gets is different. For the terrestrial planets, which are closer to the sun than the asteroid belt, they're all being hit by the same population, but you're quite right that in its position closer to the sun, Mercury receives more of these, and in addition, they're traveling at higher speeds because the sun has accelerated them to such a high speed before they come in to hit Mercury. So you would expect to see a different size distribution of craters because they're coming in at higher speeds, and with more energy, they'll make bigger craters. And so each planet does have a unique crater population that depends on its position in the solar system. An interesting talk that I went to while I was at LPSC had to do with the cratering population of the outer planets, and particularly the moons of Saturn, which it turns out that they get mostly impacts from comets, not asteroids. Very few asteroids get flung out to the Saturn system. And comets have quite a different size distribution from the asteroids. And one particularly interesting paper that I saw showed that it appears that there has been some kind of, they said, monster eating comets smaller than 5 kilometers in diameter over the age of the solar system. So if you look at places that were cratered way back when, a long time ago, you see a crater population that has lots of smaller craters. But if you look at surfaces that have had their cratering records wiped out and then got re-cratered, places like Dione, which had some volcanic activity before it finally solidified into its current solid surface, you actually find that it doesn't have nearly as many small craters. And the weird thing about that is that it means that it has many fewer craters than you would expect for a surface of its age, because these small comets have just disappeared. So the cratering record depends on its position in the solar system and also on what bodies were available to cause the craters in the first place. And I think maybe
so it's amazing really how everything's so dynamic. Sorry, we continue to have lag. And another question that we're getting is coming from Bridget Shiran, who asks, is there any chance that you could go into more detail about the type of metals and where they came from that were found in these ancient exoplanets around these Metalpoor stars? Ian, I'm going to ask you to go ahead and answer this one.
Yeah, and I think the answer really is we don't actually know much about these exoplanets. We just know they're there. These two exoplanets are in orbit around this Metalpoor star. The star is about 375 light years away, so it's actually in our neck of the woods, if you like. It's not too far away, but basically. We don't really know the composition of these planets because all the astronomers are doing, they're looking at the wobble of the Metalpoor star, and all they know is there's something pulling gravitationally on the motion of the star, so it's kind of wobbling from their point of view. And they were able to deduce that there are two planets. One is got an orbital period of 7 days, so it's very, very quick. And the other has a longer orbital period, around about 200 to 300 days, I think. But that's all we know. They've got an idea about the mass. I think one is around about Jupiter mass. The other one is about 3 times Jupiter masses. But we don't know anything about their composition. We just know that they carry mass. We know that they're there. I think there needs to be further research into how these planets could form, because there was, I think I received a few questions asking whether, the star has been around for a very long time. Didn't it just steal these planets from perhaps another star system over its period of time? Because after all, it's been in space for 13 billion years. There's plenty of time to gravitationally grab a couple of planets from another star system. But scientists say that's unlikely because they wouldn't be in such stable orbits. So these things, they did form. They probably did form from the gas and dust that actually built the star in the first place. But as for their composition, we just do not know, because heavier elements are formed inside the cores of stars. And as this star comes from a population of one star, very, very long ago in the history of the universe, it wasn't until much later that other stars formed from the bits of gas and dust from supernova explosions and other dead star stuff, that heavier and heavier elements could have formed. So it's a real conundrum as to how these planets could have formed, and there's probably going to have to be some rejigging of planetary formation theories. But I don't know, I don't think the scientists who actually undertook this research are that surprised, even though it is a record breaker and they're very proud of their achievement. I don't think they're really that shocked about it. But as for the material that came from the planets, so far it looks like it came from the same material that made the star. So they're going to be very different worlds to what we know and understand. They're probably going to be gas giant of some kind of description. They're certainly not going to be solid. And as we know, if you look around, metals and any element heavier than lithium is quite useful in the construction of planets. So it's going to keep planetary scientists and exoplanetary scientists busy for some time as to how these planets actually formed in the first place. So this is like the first big discovery of this kind. So just keep watching the news. I think there's going to be some more revealing facts about these Metalpoor stars that we've previously not really understood.
And we also have some people asking for more details on the Apollo engine adventure. For example, what does NASA think of all this? And the NASA statement basically is, well, this is exciting. People are going to be enthusiastic about it. We're looking forward to more information. Bezos apparently has had some contact with NASA, at least to say that he'd like to see one of the engines go to Seattle. But this is still apparently very early stages in terms of figuring out how they're going to get these engines, or even if they can. It's possible that these are so corroded after 40-plus years that they won't be able to really bring them up. It's a little bit fair game when it comes to these sorts of salvage operations, and so I don't think that there's going to be any problem getting permission to go down and retrieve these things. Another person asks, well, how many of these engines are out there? And there were 10, by the way I figure it, there were 10 Apollo missions that had that Saturn V liftoff, and so could be 50 engines because each of them used 5 of these big F-1 rocket engines. In fact, Kurt Newport, the guy I talked with, I mentioned, who had brought up the Liberty Bell, said he mapped out where all these Saturn stages went down. And one issue might be make sure you've got the right engines. You might have to go to the trouble of checking the parts numbers to make sure that you have something from Apollo 11 rather than, say, Apollo 10. So it's going to be an interesting exercise, and a lot of people who are really keyed into space history, like Rob Perlman at Collect Space, are just itching to be on that boat when they go out and try to retrieve these things.
Yeah, and we've just had a question as well concerning a recent Discovery News article. It's actually written by my colleague, Ray Villard, and he wrote about the 4 ages of the universe and what is going to be the 5th age of the universe. Now, this is a really kind of philosophical article in some ways, and it was kind of out my ballpark, but when he pitched it to me and said, look, is this a good idea to write that? Yeah, no, it's certainly a brain teaser. Basically, he's reporting on some research that came out in a paper recently, and he's basically discussing there's so far 4 ages of the universe. I think they call them the physical age, when the universe actually began and energy was everywhere and it started forming particles. Then it went on to form, stars, planets, and all the good stuff. Then there was the chemical age, where chemical interaction started. Then there was the biological age, I think. And these researchers now say we're going through the cognitive stage, where you actually have life forms in the universe. The universe has developed to such an extent that it's able to accommodate, it has the complex chemical interactions down, it has the chemistry for life, and now this life has gone up to another level. And we would, of course, fall in what we think we fall in the cognitive age. And so what's after that? And his argument is basically that these cognitive aliens, these cognitive life forms, will become so advanced that they are going to be able to alter the space, the environment of the universe around them. And this goes into some really kind of science fiction discussions, but also some, really far-flung science fact discussions about perhaps aliens could actually harness the energy of an entire star or of an entire galaxy. So in the future, I mean, we don't believe there's any such alien civilization out there yet, because there's no evidence for it, although we're still looking. There could be a situation, perhaps in billions of years' time, where this 5th age would allow aliens to adapt their own galaxy to suit their needs. Now, kind of far out there stuff, but it's quite an interesting discussion. I think it kind of verges more into space philosophy than science fact, but it's certainly an interesting discussion.
And then I just wanted to jump in with one other little update from Lunar and Planetary Science Conference, because it's on a talk. Nancy Atkinson just posted an article on Universe Today about the ongoing debate about what carved the channels on Mars. And there are these gigantic outflow channels. You look at them and you think water carved them. But there remains debate in the scientific community about, well, maybe we didn't actually need so much liquid water on Mars to carve these channels. It could have been lava. And Alfred McEwen, who is the principal investigator on the HiRISE high-resolution camera on Mars Reconnaissance Orbiter, gave a talk that addressed the most recent challenge to the idea of there being water flowing through these channels. And he said, well, no, I can point out some channels that definitely, if you look at them geomorphologically, it matches water much better than it matches lava. However, he said that he also found, while he was doing this work, evidence that while water probably did carve these channels, the water may only have been there very ancient in Mars history, and that most channels on Mars are actually now plated, filled in by lava flows, and that those young lava flows reset the crater counting ages of the floors of these channels. So they make the channels look a lot younger than they are, when in fact the water activity happened a long time ago, and it was only volcanic activity that happened more recently. So it's kind of an interesting compromise on the idea of, was Mars wet enough recently enough to have carved these outflow channels, or was all the water activity on Mars really a very long time ago and we've only had volcanism since then? It was a fascinating talk, and Nancy did a good job of writing up the article. So I think I'll hand it over to Pamela now to close things up.
And I feel like I needed to start talking just as you said my name so that hopefully the lag wasn't too bad. We'd like to thank all of you who came this week and joined us for the Weekly Space Hangout. We will be doing this again next week when we also have Nicole Gugliucci here, and we will both be signing in from Southern Illinois. And we will be posting this on YouTube, and you can see all of our past episodes there as well. So don't forget to check all of that out, and check out all the other shows that we have as well. Fraser Kane and I record Astronomy Cast Mondays at noon Pacific time, 3 p.m. Eastern. We have the Weekly Science Hour, which next week will be hosted by Emily Lakdawalla, and that's at 4 p.m. Wednesdays Pacific time, 7 p.m. Eastern. And we all bring you various news from all of our different sites, so circle, so add to your Twitter feeds all of the people who are here. Again, it's Alan Boyle, Emily Lakdawalla, Ian O'Neill, and I'm Pamela Gay from Starstrider. So thanks all of you for coming.
Bye.
Live long and prosper.